All right. So let's try a tape diagram, since some of you are comfortable with that. Okay, so am I doing an increase or a decrease?
Increase.
Okay, so an increase looks like, here's my x. An increase is going to add a percent onto it, right? X is always what percent? 100. I'm adding 30%. What is this 50? Is that my original or is that my new number? How can you find a 30% increase to 50? So I want to find x is 50. Y is what I want to find. Okay? So y is what percent of x? 130%. So y is 130% of x. Okay, so the equation would be y is 1.3 times 50. Okay, that's one way to do it. I can multiply it by 1.3, yes? 65, okay. There's another way to think of it. I can think of, I want to take 30% of 50. 30% of 50. I'm going to write that as a decimal. Of means to multiply. So I'm going to multiply 0.3 times 50. That's going to give me 15. That's 30%. What am I doing? An increase. So what am I going to do to that? I'm going to add it to the 50 and get the 65. This is another way to do it. This is using tape diagram with an equation. This is just finding 30% of a number and then adding it to it because it told me I increased. Okay? Questions? Kimberly? You look confused.
The first one I understand with the tape diagram, but the second one you multiply by 50. Why did
I'm finding 30% of 50. Of means to multiply. 30% I wrote as a decimal, 0.3, times 50 gives me 15. That's what this amount is right here.
But then I'm confused why you have to add 50.
I added 50. All this is, this 15 I got is just the 30%. If you come over here and look at this, from here to here is 15. From here to here is actually 15. 50 plus 15 gives me the 65.
Okay, I forgot that the x equals 50.
Okay, good. You thought through it. All right, two different ways to do it. They both work. All right. If you know that a 30% increase in a quantity is 50, how can you find the original amount? Oh. Well, let's look at it a couple of ways. Let's look at it with a tape diagram. Let's look at it, do I have yellow on here? No. Let's look at it with a double number line. See where we end up, okay? All right, a 30% increase in the quantity is 50. So we don't know the original, do we? So that's going to stay x. A 30% increase means we added on to this 30%. X is always 100%. This is our new amount. Do we know our new amount? This is 50. Okay, y is what percent of x? Y is 50 is what percent of x? What percent is that? 130%. I'm going to write it as 1.3 of x. I'm going to multiply it by x. So what am I going to do to solve that? Divide both sides by 1.3, and what do I get? 50 divided by 1.3. You got calculators. 50 divided by 1.3?
38.
38?
I guess we'd round down.
Change it back into a fraction. Divided by 1.3, let me see. Yep.
38 rounded up.
No, I'm sorry, 50 divided by 1.3. Jeez Louise, Miss Blair's just...
Yeah, you did that.
38.5. Okay, change it back into a fraction and I'll show you how to do that. See that button? 38 and 6/13. Not a very pretty number, but that's okay. Do you understand the process that I used? Do you understand why I put the 50 there instead of as the x? Okay, and do you understand where the equation came from? Okay, we good? Do you want to see it with a double number line? Okay, our percent is down here and then we have a number. So we've got 100% and we have 130%. Our new is y, x is our original. Where am I going to put that 50? Right here, right? Okay, just like before, y is what percent of x? Y is what percent of x? I end up with that same equation. Y is what percent of x?
So that means your interest rate would be 6/13.
Mm-hmm. So this number right here would be 38 and 6/13. Okay? Questions? Okay? How can you find a 30% decrease to 50? What do you think? Can I take 30% of 50 and subtract it from 50?
Yes.
Yes. Okay, when we did the increase, we added it. Could I do a tape diagram and find the equation? Okay, what does a decrease look like? Am I adding a piece or taking away a piece? I'm taking away a piece. That piece I'm taking away is, so what percent am I left with for y? 70%. So here's my y, here's my x. What is that 50? Is the 50 the x or the y? The original or the new?
The X.
It's the x, it's the original. Okay, the equation becomes y is what percent of x? Y is what percent? 70. I'm going to write it as a decimal of x. So I'm going to take 0.7, and it makes sense. If I'm decreasing it by 30%, if it's on sale for 30%, what percent am I going to pay? 70%, right? Okay, I'm not so concerned about the answer, but I think it's 35. Okay, does that make sense? Okay, I can also just take 50. I want 30% of 50, so I can multiply it by 0.3, and that's going to give me that 15, and then I'm going to subtract it because it's a decrease. Okay, that's another way of doing it. Either way works. It's how you think of it. Okay? Questions? If you know that a 30% decrease in a quantity is 50, how do you find the original quantity? Well, let's look at it. I think it's easier to see this on the green. Okay, I'm going to draw the decrease first. Okay, X is always 100%, and Y is gonna be this piece right here, right? Okay, what is that 50?
The line.
The Y. Okay, just like before, Y is what percent of X? So what are we gonna do to both sides? Divide by 0.7. Okay, makes sense? Okay, so like I said, you just have to figure out what's the original 100%, what's the Y, what are the numbers, where did they go? Okay, and you just got to ask yourself, is it a decrease or increase, and what does that look like? That's a decrease. An increase adds a piece on. If you're using the double number line, a decrease takes it to the left of the 100. If it's an increase, it takes you to the right of the 100%. Everything is based off of the X 100%. All right, let's try some practice problems. A bakery used 25% more butter this month than last month. If the bakery used 240 kilograms of butter last month, how much did it use this month? I'm going to use a double number line. So I have butter here, and I have percent here. And is this an increase or a decrease?
Increase.
Increase. Okay, so I'm going to put 100%, and it's increasing by 25%, so that means my new percentage is 125%. So now I have to decide, where does this 240 go?
It goes to the 100%.
Why?
Because since it's a 25% increase, that means it'll be a bigger number, aka it should, you know.
And it says
Last
month. That's going to be your original. Okay? So we're going to find, we want to find Y. So remember, everything is based off of X. Y is what percent of X? Y is 125%, which I write as a decimal, 1.25. Of means to multiply, 240. Multiply it, tell me what you get. 300?
Yes.
Okay, so our answer is going to be 300 what? Kilograms of butter. Questions? And did I bother to write in all the other numbers on the double number line? No. You only need 4 points. Okay? I don't bother with the rest of it, but it helps me see it. If I was to draw the tape diagram, there's my X. It's always 100%. I'm adding 25%. This whole thing is my Y. And we know that, what do we know? We know the original amount of butter was 240. We'll end up with that same equation. That's just a different representation of it. Okay, my other alternative, I could have taken 240 and taken 25% of 240. So that means I'm going to multiply 0.25 times 240, get an answer, and then add it on to the 240, which is going to be 60. So then I take the 240 plus 60, and that gives me 300. That's another way to do it. Looky there. 3 different ways to do the same problem. Okay? Whichever way it clicks in your head, I'm fine with. All right, you got that written down?
Yep.
You should after all that talking I just did. Everybody ready at home? All right. Problem number 2. Last week, the price of oranges at the farmer's market was $1.75 per pound. This week, the price has decreased by 20%. What is the price of oranges this week? I'm going to use my double number line. So I've got price of oranges right there, and I've got percent right here. I've got 100%.
Which is 1.75.
Okay, and then it decreased by 20%. So what's my new percentage? 80%, because this is a 20% decrease. Okay, now we gotta decide, where does that $1.75 go? Is that my original or is that my new?
Original.
That's my original because it says last week. Okay, Y is what percent of X? We don't know Y. That's what we want to know, right? Y is what percent? 80% of means to multiply X $1.75.
Which equals 1.4. I'm pretty sure.
$1.40. Okay, so this is money, so the price of oranges is now $1.40 per pound. Okay? Another way to do it is to find 20% of $1.75 and then do what with it? Add it or subtract it?
Subtract.
Subtract it because we're saving it, right? It's a decrease. Okay, makes sense? Or I can draw my tape diagram. Here's my X. That's my 100%. But we know it did what? It decreased. I should have thought of that before I started. Decreased by 20%, so that left 80% here. We know this is our new, and we know this whole thing was our X, which was $1.75. We end up with the same equation, just a different picture. All right? Making a little bit more sense. I know some of you were confused yesterday, but I'm telling you, the more you do this, the more comfortable you're going to get. Okay? All right. What am I doing on time? I got 10:40. I got till 11:30. Okay. Noah thinks the answers to these two questions will be the same. Do you agree with them? Explain your reasoning. This year, a herd of bison had a 10% increase in population. If there were 550 bison in the herd last year, how many are in the herd this year? And then he says this is going to be the same answer as this year. Another herd of bison had 10% decrease in population. If there are 550 bison in the herd this year, how many were there last year? What do you think, Jahan? Same answer?
No, because one's increased and another one's decreased.
But they increased and decreased by the same amount, so does that take you back to the same number?
For the original number, yeah.
What do you think?
I still think that.
What do you think, Jaden? You think it's the same number? What do you think, Alan? We decreased and we increased the same amount. Are we going to end up in the same place? It says the answers to the two questions are going to be the same.
It says if the last year, the 550.
Okay.
Last year.
All right.
It says this year.
Okay.
Yeah, I don't think they're gonna be.
You don't think they'll be the same?
No.
All right, let's try it and see. Okay. This year, a herd of bison had a 10% increase. You want to do tape diagram or you want to do double number line? let's do double number lines so you get a little more comfortable with it. All right, so we've got bison here, and we've got percentage here. We're gonna have 100%. And in the first one, we have an increase, so we're going to 110%. Where am I going to put the 550?
Original?
The original, so that's X, right? And we want to know that. Okay, let's look at the second problem. This is the bison still. This is percent. We've got 100%. What are we doing with a percentage? We're decreasing by 10, so the new percent is going to be 90 because it's a decrease. Okay, and where are we going to put the 550?
On Y.
On the Y. So what are we finding 10% of? Well, in this case, we're finding 10% of 550, right?
Yes.
And adding it onto it, right? In this case, our answer ends up being 550. We are taking 10% of some number, which is going to be bigger or smaller than 550. Look at it on the number line. Is it going to be bigger or smaller?
Bigger.
Bigger. Okay? So, are we going to end up in the same place? Because this answer is going to be bigger too. Let's see. So Y, we don't know, is 1.1 times 550. What do you get?
605.
605. Okay. Over here, we know Y. 550 is 90% of some number. Okay. So what are we going to do to both sides here? Divide by 0.9. So what do we get here? See if we get 605. Do you?
You get 611.1.
Okay. Did we end up with the same answer?
No.
No. It's all of what you're taking percent of. And you always take the percent of the original. And the original isn't the same here, is it? Is the 100% the same number? No. This 100% is 550. This 100% is going to be larger than that. Okay? Make sense?
Yes.
All right. Anybody need more time at home? Okay. Still on Noah. There we go. Elena walked 12 miles, then she walked 0.25 that distance. How far did she walk altogether? Is this an increase or a decrease?
Increase.
Increase. Okay, so here's my X, that's her original. She added on, okay. We know her original amount is 12, and then she added on 0.25, which, what is that as a fraction?
Wait, what? Say that again.
What is 0.25 as a fraction? 1/4. So we added on 1/4. So that's kind of what it would look like, and this is her new amount. Okay, so am I going to take 12 and add 0.25 times 12? Think about what this says. This right here is 12, right? And then what is she adding on? 0.25 of 12. So is this true?
Yes.
Yes. Okay, am I going to take 12 and multiply it by 1 plus 0.25? Is this 100% right here? Is this 1? This is 1/4, 1/4, or 0.25 if we want to write 0.25. Is this 1 right here?
Yes.
And then we added another 0.25, and then we're going to multiply the whole thing by 12 because that's the original, right? That one works. How about 12 times 1.25?
Yes.
Yes, because what is this right here?
1.
1.25, right?
Yes.
Because from here to here is 1, and then we added
25.
0.25 onto it, so that one works. How about just 12 times 0.25?
No.
That's just finding this distance right here, the piece she added on. Okay? How about 12 plus 0.25? That's just adding 0.25 miles. Okay, and that's not what she did. So A, B, and C. Okay, questions? Tape diagram, help you see it? Then draw it. Doesn't take that long. Okay, who needs more time? Some of y'all aren't writing this stuff down. You're not going to have anything to take a screenshot of. All right, problem 5. A circle circumference is 600 meters. What is a good approximation, cannot say that word, of the circle's area? Well, I'm going to draw a circle. The circumference equals 600 meters. And I want to know the area. Well, circumference is, how do I find circumference? Or we can use our cheat table. Do we want to use our cheat table? Our little flow chart. C, D, R, and then A. You want to use that? Remember that? All right, so C equals 600. What do I do to get the diameter? Divide by 3.14. What do you get? Probably some nasty number. You got calculators, don't you?
Yeah.
Do you have a calculator in your notes? Okay, let's go. What's 600 divided by 3.14?
And what are the big numbers?
191.0.
All right, we'll just call it 191. Because we're asked approximate. Okay, and we're using 3.14, and that's already an approximate, right? All right, so if the diameter is 191, what's the radius? What do we do to get that? Divide by 2, so what's the radius?
95.5.
95.5. How do we find the area? 3.14 times 95.5 squared.
And equals 100 squared.
What do you get? Well, are you going to get 300? This is almost 100, right? 100 times 100 is 10,000, right? So 10,000 times 3 is already going to be, is that going to be 300?
No.
No. Is it going to be 3,000?
No.
No.
Is it going to be 30,000?
Yes.
It won't be 300,000. Little mental math there, instead of squaring 95.5. That's almost 100. 100 times 100 is 10,000. And then we know pi is 3 and a little bit more. Okay, questions? Oh, that flow chart worked really nice for that one, didn't it? Okay. All right, last question. And then we'll do the practices, and I'll stay online if you need help at home. The equation D equals 3t represents the relationship between distance in inches that a snail is from a certain rock and the time in minutes. What does the number 3 represent? That's a COP, but what does it mean in this situation? Think about it. What's T? Time, and that would be in 1 minute, right? So what is the 3? If I make T1,
3 inches.
3 inches. So the 3 represents 3 inches per minute. Okay. How many minutes does it take the snail to go 9 inches? Well, we can use our equation. D equals 3T. What is this 9 inches? Is that D or is that T?
That is D.
That is D. This is going to equal D. So I'm going to come down here and I'm going to put, I'm not going to put 3. I'm going to put 9 equals 3T. Then I'm going to solve for T by dividing both sides by 3. So T equals 3. And what does that 3 mean?
3 minutes.
3 minutes. So it takes him 3 minutes to go 9 inches. How far will the snail be from the rock after 9 minutes? D or T? This is T. So this time we're going to substitute T with 9. So D equals 3T. We're going to use that same equation. We don't know D, but we know T is 9. So we get the distance is
18. Wait.
9 times 3 is 27.
I mean 27. Yeah.
27, and it's going to be 27 what? Inches.
This way.
Yeah.
Or you could, since you already know that in 3 minutes the snail goes 9 inches, and you just multiply 3 times.
True thing, true. You're thinking going this way. I'm thinking going that way. Both ways work. Questions? Starting to feel more that coming back? Okay, it shouldn't go away. All right. So now what we're going to do is you have been assigned Khan Academy percent problems. Okay, tape diagram, double number line. Use those tools to help you solve these. All right. And those of you at home, will stay on if you need some help till 11:30 when we eat lunch. So go ahead and get to work. You also have a check-in to do, okay? And that shouldn't take you very long. I think it's 5 questions. All right, have a great weekend. Yes, you have a check-in to do. Add that to this